Okay, guys, I'm going to give you some information. You're going to draw the free body diagram, and you're going to determine the force of friction acting on the object as it slides to a stop. Okay, so draw your box. Okay. I'm going to give you the mass of the object. And I'm going to give you the acceleration of the object as it slides to a stop. Okay? So draw the free body diagram. I've got it started for you. You need to draw in the forces. And determine the force of friction acting on the object as it slides to a stop. Vertically, which forces are acting? Okay, so force due to gravity and your force normal. So we have this force of gravity, we have this force normal. What can you say about those two forces? They are balanced, okay? So Fg equals the negative of Fn. They're just equal and opposite, right? They're balanced. So we're not really interested in those two forces. Which force are we interested in? The force due to friction. So here we have a negative acceleration. So the acceleration would point in the same direction as the force. So which direction would you like the force vector for friction to go? Force of friction to the left. And is there any other force acting to the right? I don't think so. The box is just sliding to a stop. So there's no applied force. This would be like you driving in a car, seeing a red light, and then hitting the brakes. As you hit the brakes, you no longer are applying a force to drive forward. You are applying a force to stop, which is the opposite direction of the motion. So this thing must be sliding to the right as it's stopping. Okay, so the net force is equal to ma. That's straight off your formula sheet. And the net force horizontally is what? The only forces acting are force due to friction. So this one you literally just have to times m and a. And you get negative what? 39.6. So negative 39.6 newtons, or in other words, 39.6 newtons left. Okay, so very, very simple question, but here's the big thing here. This net force side of the equation is a sum of all forces involved. So the vector sum. So these guys balance out. So the only force that's left over is FF. So the net force is only one force. That's the most important thing. We're going to be getting into some questions later on in the next week where this net force is going to be quite challenging. There's going to be lots of forces involved. Okay, let's try one more. Okay, this time I'll give you the free body diagram and you have to find the missing variable. Okay. In this case, just for clarification, because I'm not the best artist, that applied force arrow is longer than this force due to friction. Okay? So the forces horizontally are unbalanced. Okay, try this one. Okay, so use the hint, use the weight to find the mass. If you know the weight of the object, you can always find its mass, because the weight is Fg, and this little g is always constant on Earth, 9.81. You can divide it out and find the mass. Once you have your mass, you have two formulas for F net. One of the formulas is F net equals ma. You know that one. That's the second law. Okay. The other formula, F net, is the vector sum of all forces. So F1 plus F2 plus ... however many forces are involved. Okay. So basically what you have here is ma equals F1 plus F2 plus ... You guys really have to know this. This one here. Ma equals all the vector sum of all the forces involved. This is the most critical information in this section. By far, the most critical formula. So you were able to find the mass by dividing out g. So this 300 newtons divided by 9.81 kilometers per second square. 300 divided by 9.81, I'm getting 30.58. They gave me an acceleration of 2.5. Now we just need to do the vector sum of the forces involved. And those are, there's only two, correct? So I can erase this ... because I know there's only two involved. I'm going to use my highlighter to demonstrate this to you. Here's one of the forces, and it's acting in which direction? That one. Okay, so let's call the positive one F1, and the negative one we'll call F2. So just to rewrite F1 and F2, it would be F applied, which is positive, and F friction, which is negative. We know that F applied is 1100 newtons. Keep the unit out. I'm just going to simplify that left-hand side. I didn't round on my calculator. I rounded on the paper, but I didn't round on my calculator. Times by 2.5, I got 76.453 if I round. Now how to solve for the force of friction. This is basic linear equations. You move the you move the FF to the left and move the 76 over here. And you have your force due to friction. So 1100 minus that answer, I got 1023.55, and then I'll just throw it down into sig digs. How many sig digs we got here? 3? So 1.02 times 10 to the 3 newtons, or you could just say 1.02 kilonewton. That would also work. Kilonewton. Hi. Well, like if you don't have the force of friction negative in the formula up there, when you go to do your algebra, you're going to be subtracting instead of adding.
That's why I'm saying instead of taking the FF this side, you have to take the 1,100 this side and then you have negative.
Yeah, if you can understand that, then go for it.
No, I'm just saying, like, is it acceptable?
If you get this answer, whatever way you understand what you're doing, as long as you get this answer, you're good. I don't know, like, it has to be lower though. The force of friction has to be lower. Yes, I do. I need to put left on there. You're right. Question. Oh, it's given up above. It was given. Sorry, dude. Up here. Yeah, so I just need to put on the, for the force of friction, I just need to put left on there. And let's just think about this answer for a bit. How many newtons of applied force are there? 1100. How many newtons of the frictional force? Just over 1,000. So which one's bigger? The applied force. So it's unbalanced, right? So it has to be accelerating to the right. Okay, you guys want to try one more now that you've seen this business here with the star? This is the most important thing. I might have mentioned it once or twice, but it didn't hit home. So now you got to really master that one, or else this whole unit is a wash. You have to master that. Okay, so I'll give you another problem. So I'll give you the mass of the box. I'll give you a coefficient of friction. I'll give you an applied force. And I'll say find the force of friction. That's what I want. Anybody know what the hint would be on this one? If they give you mu, FF equals mu Fn, which is essentially Fg. Good. So that's the hint on that one. Sure, what's your question? I don't know if it's balanced or not. I just drew it that way. This question mark, I don't know. So yeah, we had a fix there. The arrow is unbalanced, left and right. So find the force of friction, and you have the hint there. Okay, so after some momentary thinking, you've seen that this is actually quite easy. So this is mu Fg, because Fn and Fg are balanced. The formula for Fg is, of course, mg. Plugging in our variables, we have 0.45 times the mass times acceleration due to gravity. And you get the force of friction here. 0.45 times 25 times 9.81, got 110. Is there 3 sig digs? 2 sig digs. So 1.1 times 10 to the 2 newtons left. So 110, obviously less than the 300. So this guy would be accelerating to the right. the forces are unbalanced horizontally. So this thing would be accelerating to the right, which means it would be gaining speed to the right. Okay, one more before you leave. Let me get it down there quickly. One more. And I'm not helping at all with this one. Okay, so I'm going to give you the coefficient of friction. So I guess you could use the hint from the last question. I want you to find the mass for this one. I'll give you the free body diagram. And I'll zoom in for you guys. Just find the mass. That's it. Yeah, 225 newtons for the force of friction. Find the mass.